morning and welcome to another fun-filled statistics video with Professor Smith. I would like to review how to identify critical values using the standard normal table. And we will use these critical values in the construction of our confidence intervals. So, in the process of identifying a critical value, the first question that you need to ask is how much is in the middle. That would be the given level of confidence. So I'm going to start off with 95% in the middle. So if our level of confidence is 0.95, that indicates the middle area. And so if 0.95 is the area in the middle, how much is not in the middle? 0.05. And that 0.05 needs to be equally divided into each of the tails because the normal distribution is symmetric about the mean. So if we take 0.05 and cut it in half, we get 0.025 is the area in each tail. I want to copy that and paste it over because it's the same area in each tail. So it's not letting me. Here we go. Thanks for bearing with me. Okay, so if 95% is our level of confidence, that's equivalent to 0.95. 1 minus 0.95 is 0.05, and the 0.05 again gets cut in half because it's equally distributed in each of the tails. So now that we have the area in one tail, we can move to our z-table. And so I am looking in here, I'm looking in here for 0.025, or the closest thing that I could find to it. And I found it, but I've got to move my view. There we go. 0.025 is located right here in the table. So to identify the z-score corresponding to an area under the curve to the left of 0.025, I follow that over and up. And I can see the intersection here is negative 1.96. So going back to file I started with, the area in each tail, 0.05, cut in half is 0.025, and we looked up that value inside of the table and we found a z-score of negative 1.96. And the other value is the opposite, or has the opposite sign on it. So the other value, if that one's negative 1.96, will be positive 1.96 because of the symmetry of the normal distribution. For this second example, I would like to identify the z-critical values for a 90% confidence interval. So if 90%, or the area under the curve in the middle, is 0.90, then how much is not in the middle? 0.10, right? And as we saw in the previous example, we need to take that area, 0.1, and cut it in half to show that each tail has an area of 0.05. Okay, so if we know that 5% is the area in each tail from taking 0.10 and cutting it in half, then we know that we are looking up 0.05 in our z-table, or the closest thing to it. So I am looking for 0.0500, and I see 0.0495 and 0.0505, and the 0.0500 appears to be right smack dab in the middle of these two z-scores, which are negative 1.64 and negative 1.65. So if we were to average those two z-scores, negative 1.64 and negative 1.65, then we would get a critical value of negative 1.645. And if our left critical value is negative 1.645, then our right critical value has to have the opposite sign but the same number. And so it is positive 1.645. The remaining two levels of confidence are noted in the slide that I provided you that looks like this. The 98% confidence interval with 0.98 as the area under the curve in the middle has 2% that's not in the middle. So 1% in each tail, critical values are plus and minus 2.326. For a 99% confidence interval, the area under the curve in the middle is 0.99. So the area under the curve not in the middle is 0.01. Cut in half has a tail area of 0.005. That's 0.005 in each tail, and the critical values associated with 99% confidence are plus and minus 2.576. Thanks for tuning in, and be sure to like and subscribe. See you soon.